back. Now answer your attendance. Afla,
Present, Miss.
Ajmina,
Present,
Amaya,
Miss. Present, Miss.
Atulya, Drishya, Jyotish, Karthik, Kavya,
Present, Miss.
Nachiketas, Neeraj, Rangit, Vaishnav, Anjali,
Present, Miss.
and Shruti.
Present, Miss.
Drisha is there. Jyotish. See, you have to join on time, otherwise I'll be marking absent. Neeraj, Vaishna and Vaishnav. Okay. So, the morning class, we were discussing about the address mapping. You have gone with the two different protocols based on that. One is the ARP protocol and another one is RARP protocol. Now, Kavya will be summarizing what we have learned in the morning session. Kavya, you can just summarize it.
In the ARP, it's used to obtain the physical address.
Yeah.
Uh,
Physical address of what? Physical address of whom?
host.
Of the destination host. You want to obtain the physical address in order to route the packet, right? So if you don't know, initially you don't be knowing about the physical address of the destination host. So in order to obtain that, you will be making use of this ARP protocol. Now, how does it work actually? Or how it is obtaining the physical address?
ARP packet includes IP address.
Okay. ARP, what type of packet? Is it a response packet or a reply packet?
Sender
Yeah.
includes
Query
IP address
packet
and
or
physical
the
address.
request packet.
ARP request will be in the form of broadcast. Request is sent to all the hosts, but
Okay.
the reply is unicast.
Unicast. So once it will be broadcasting, so whichever hosts are connected to that network, they will be getting that the packet, and whoever is having that. Now, what is inside that packet actually?
IP.
You have three things. One is the logical address of the sender, the logical address of the receiver, the physical address of the sender. Three things will be there, but you don't have the physical address of the receiver. But if you want to transfer that packet through the physical networks, you need the MAC address. Okay, so making use of that protocol, you will be able to obtain. Now, next, second one.
Reverse address resolution.
Yeah, reverse address resolution protocol. Okay, what is that? How does it work?
Used when physical address of the host is provided.
Yeah, in which situation you require the physical address or logical address? What do you require at the sender side? You know the physical address of the device, but you don't know the logical address of that device, of the sender. So you want to obtain what? You want to obtain the logical address of the sender. This case happens only in diskless machine, where if there is any computer which does not have a secondary storage, that computer make use of this RARP protocol. It is not compulsory that all the machines will be using RARP. Whoever is not having a permanent storage, they will be making use of this RARP protocol. So when you are booting it for the first time, sometimes you won't be having the allocated the IP address. So in order to obtain that, you will be making use of this RARP protocol, right? Okay. Now after that, what we have learned?
DHCP.
DHCP. Now, what is the expansion of DHCP?
Dynamic host configuration protocol.
Dynamic host configuration protocol, right? Okay. Now, what I was telling about that, what is dynamic host configuration protocol? Now, all of you listen here. Now, what is dynamic host configuration? What is its importance is, see, whenever every computer, if it is connected to a network, it should have the IP address. If you want to communicate each other, you require the IP address. Now, IP address is acting as the identifier. Now, this IP address will be assigned to our system by two ways. One is manually you can assign it, or automatically you can assign it. So that is called statically or dynamically. So static IP is where the user assigns the computer or your laptop or your device with an IP address manually. Manually, you are setting everything, the subnet mask, then the IP address, then the default gateway, everything you are manually setting, and you are getting the configuration. I mean, you are connecting to the internet. But once the number of hosts is more, this will become difficult. So you will be having a special host to provide all these services, to provide the IP addresses. So that is called it as the DHCP server. So when your laptop or PC, when you are automatically doing the IP settings, when the automatic IP settings are enabled, it will be connected to the internet. And the laptop is running this DHCP protocol. That is the same in the diagram actually. So who is assigning that IP addresses? The DHCP server assigns that IP address to the laptop. So once it is assigned, you will be able to get the information from a particular website. Until and unless your laptop is not configured with your IP settings, you won't be able to obtain the IP address. I mean, you won't be able to visit any of the website. You won't get any details regarding the website, what you have searched. Okay, so that process of obtaining this IP address from the server by the client is called it as the DORA process. I repeat, DORA process is nothing but it is the process of obtaining IP address from a DHCP server by the DHCP client. Here, client means here your laptop is acting as the client. So if server is providing the IP address to the laptop, so that process is called it as DORA process. Now, what does this DORA? D stands for discover, O for offer, R for request, and A for acknowledgement. Now, what is happening? So suppose if we connect your system or your device to internet, initially, it won't be having any IP address. So the client or your laptop, what it does is, it will send a discover message to the server. First, initially, the laptop or the DHCP client, it will send a discover message to the DHCP server. Now, what the DHCP server will do is, it will send an IP address in the offer message. Okay, so the server will be sending an IP address in the offer message. So what the client will do is, it will ask the server to allocate the offered IP. Whatever IP address is given, the client will provide a request to the server to allocate that offered IP address to the client. So that request, that is in the form of a request. Okay. Now, after that, the IP address will be assigned, offered IP address will be assigned to the laptop, and it will be sending an acknowledgement with an acknowledgement message. Okay. So once the acknowledgement is received, your laptop or the client configure the TCP/IP settings in your operating system. And that is how your laptop is accessing to the internet. Okay, understanding? So if you want to connect your computer to the internet, initially you won't be having an IP address. So you will be requesting, you will be asking the server to provide an IP address. So that process is called it as the DORA process. Initially, the discover process takes place and the server will offer an IP address and the client will request to allocate that offered IP address, and finally the acknowledgement is done. So once the acknowledgement is considered, the client can configure to the TCP IP settings automatically, and finally he can log into a website. Right? Okay. So this DHCP or the DORA process. So in one way you can tell that dynamic internet protocol or IP addressing is where a computer gets an IP address from the server. Automatically it is getting the IP address from the DHCP server. So I told two ways you can assign IP address. One is statically and the other one is dynamically. So dynamic IP is where your device or your computer gets an IP address automatically from the DHCP server. So automatically, what all things it does. So once you type IP config in your command prompt, it will be displayed automatically. So the IP address, what you're using, and the subnet mask, the DNS server, the gateway, and everything will be displayed in your screen. So try that if you have your PC, just command prompt, you just type IP config and see what is happening. Okay, so you can tell DHCP is a service that runs on the server. If you're using Microsoft server, that the server will be, Microsoft server, or it can be a Linux server. Or you can also tell that the DHCP is a service that runs on routers. So it will be providing the IP address to a device. Understood? What is this DHCP protocol? So DHCP is a service which runs on the router or which runs on a server. Okay, so this is the third type of protocol, dynamic host configuration protocol, that is used to obtain the IP address automatically to your device from the DHCP server. And that process is called as the DORA process. Understood? What is DHCP? Yes or no? Neeraj is there? Neeraj is not there. Vaishna? Vaishna is also not there. Okay. Now, Nachiket, understood what is DHCP? Yes. Okay. Now we will move on to the next type of protocol called ICMP. ICMP. ICMP means Internet Control Message Protocol. Internet Control Message Protocol. Now, what is its function? Actually, this protocol, that is ICMP, is mainly for error handling. When you are dealing with your internet protocol, that is IP, I have told you it is having some deficiency, that is, it is not having any error control mechanism, or it is not having any assistance mechanisms. So ICMP is designed to compensate the two drawbacks of this IP internet protocol. One is error control protocol, error control mechanism, as well as the assistance mechanism is absent, or it is not there in your internet protocol. So this ICMP is acting as a help to the internet protocol in providing the error handling technique. Okay, now what is this working? So you can see in the diagram, two hosts are connected through a network, and you are making use of two routers also. Okay, so the router's function is it will be informing whether you can connect from host 1 to host 2. Now, what happens if if you don't have any direct path to connect from host 1 to host 2? What happens if the packet is not delivered by the router? The router is not able to deliver the packet. Now, what happens if something goes wrong? And the solution is the ICMP protocol. If you are sending some packet to the destination, what happens if the router cannot send that packet? So what it will do is it will send an error message stating that it is not, I am not able to deliver the message to the destination. In your diagram, you can have host 1 and host 2. So the router which is connected from host 1 to the to the network, that router will inform whether it is able to deliver the packet from host 1 to the next network. Right? So if it is not able to do that, it will send an error message. Okay? So what happens if something goes wrong? That also is the case. That what happens if the router must discard that packet because it is not finding any route to the destination. So all these cumulatively, you can call it as an error, right? So that error message is, that error handling, that reporting is done with the ICMP protocol, Internet Control Message Protocol. Now, usually it is being used by the network devices like routers to send error messages, right? Now, you have got, okay, now you have got a general format for this ICMP messages. What is the format? What is the message format? Generally, two types of messages you have got. One is called it as the error reporting messages. I have told ICMP is used to report some errors if a router is not able to deliver the packet to the destination, or if it is not finding any route to forward the packet to the destination. So two types of messages you can have. One is the error reporting messages. Now you can see in the diagram, you can have different types of error reporting messages. One is the destination is unreachable. You are not finding the route, correct route to reach the destination. The next case is source quench. Source quench means it is a request to decrease the traffic rate of data messages, what is sent to the destination. So maybe the sender will be sending the data in a fast manner, so the router is not able to process that. So at that time, it is a request. They will send a request to decrease the traffic rate. So that is called it as source quench. Now the third type of error reporting message is the time. Once the time is exceeded or you have any parameter problems. Now if you want to redirect it. So these are the different types of error reporting messages. Okay, so the frame format will be containing either the error reporting or the query message, what you are going to see just now. Right? So two broad categories of messages. Out of that, one is the error reporting messages. So what it will do is this will report problems that the router or host, what it encounters during the process when it is, when it is processing the packet, what problem it is encountering, that will be reported. That may be the destination unreachable. That is the cases, what I have told. Like it can be more traffic, or it can be the time is exceeded, or whether the destination is not reachable, like that. Okay. Now the second type of messages is called it as the query messages. So query messages, you can have different types of query messages. One is echo request and reply, timestamp request and reply, address mask request and reply, router solicitation and advertisement. These are the various classification. Now you just understand what is that query message. Now query messages are, that is, it will help the host or a router or a network manager to get specific information from a router to another host. So if you want to obtain some information, a specific information from a router or to another host, you will make use of this query messages. Okay, so these are the two types of messages in ICMP. One is the error reporting messages and another one is the query messages. Now you have the message format. You have the message format, and in that the first field you have a header section and you have a data section, right? Now the header is it is an 8-byte section, right? Now the first field, what you can see here, it is the type. So ICMP type. Now what does it define is, it will define the type of the message. What type, whether it is an error reporting message or whether it is a query message. You should be able to identify what is the type of the message. So that will be specified in the first field. Now the next one is the code. So the code field specifies the reason for that particular message type. Now what is the reason? That will be specified in the code field. Now the last common field, it is nothing but the checksum. You know what is checksum. So that field is the checksum field. Now the rest of the header, that is meant for each message type. Rest of the header, you have a header section and then only the data section comes. So whatever information related to that particular type of the message, that will be coming in the that block, that field. Now you have the data section. Now data section, maybe if you are using the error reporting messages, the data section, it carries information for finding the original packet which has got an error. Okay, so you have two type of messages I told. One is the error reporting as well as the query message. So if your message is an error reporting messages, the data section, what it carries is, it want to find out the original packet. So what all details you require for that, that will be contained in the data section. Right? Now, if it is a query message, now the data section, what it contains is, it carries the extra information based on the type of the query. Okay, so the main responsibility of this ICMP protocol is to report errors. Now they are always reporting the errors to the original source, because who knows the whole thing about the packet? Only the source host, right? Source host only knows where is the logical address, where is the physical address, what is the packet about thing, what is the route, everything. So whatever error is there is happening while the data is sent from the sender side to the destination host. The router, if it is not able to process the data, they will send the error report to the source. That is what I have just, ICMP always report the error messages to the original source. Okay, so this is about the ICMP protocol. I have told two different types of messages, right? So ICMP is mainly done for the error handling at the network layer of the TCP/IP model. You have got, I told, when you want to send a data from the source host to the destination host, sometimes the router won't be able to process that packet. Maybe some error will be happening. Maybe the route won't be found to where the destination is connected. So in that cases, using this ICMP protocol, they will send the error reporting messages to the source side. Now, two types of errors can be sent. One is the error reporting messages and the other one is the query messages. Error reporting, you can have various classifications, and query messages also, you can have various classifications. Now, what are the different fields in that message format? That was asked once in for the university examination. What is ICMP? What is the message format of ICMP? So when it is asked, you should be able to write about. So start, what is ICMP? You just write what is its function and what is the message format, how you can represent it. Okay, so two type of errors, error reporting as well as the query messages, and mainly it is done for the error handling. I mean, usually the network layer protocol, that is IP protocol, won't be able to do that. So this ICMP will support that internet protocol in sending the error messages, right? So there comes the importance of this ICMP. Okay, so what I have told from the morning, I mean, this class is the DHCP, Dynamic Host Configuration Protocol. And the second type of protocol what we dealt with is the ICMP. ICMP is nothing but Internet Control Error and Message Protocol. And that is mainly done for the error handling process. Okay, now the third type of protocol. You can have one more type of protocol that is called it as IGMP. Hope you remember where are the locations of all these protocols. When we are dealing with the TCP/IP protocol, all these protocols are present in the network layer, right? Now this IGMP protocol, usually I have told you, you can have two types of communication. One is unicast communication and another one is the multicast communication. Unicast means, what it means? Unicast means one-to-one communication. Multicasting means one-to-many. You want to send the message to a group of hosts. So that is multicast communication. So this IGMP, that is Internet Group Management Protocol, that is the protocol meant for multicasting, right? It is the protocol that is involved in multicasting. It is also a companion to the IP protocol. The main protocol in the network layer, that is nothing but the IP protocol. Okay. Now, if you want to do the multicasting in the internet, what you require is you require routers. Okay, so you require routers where the routers will be able to route the packet towards so many destinations, to so many hosts to where it is being connected. So each time when they are processing that packet, the routing table also gets updated. Okay, so if you want to do multicasting in the internet, you need routers that are able to route the multicast packets. Each time when you do that, the routing table will get updated. Now, consider this figure. You can see a diagram in your slide. So now consider that figure. Now you have a multicast server there and you are having many hosts that is being connected, right? So suppose if the server is sending a multicast traffic to some of the hosts which is connected on the network. Now, if you want to do that, if you want to deliver that multicast traffic to the host, you require a protocol. And that protocol is nothing but the Internet Group Management Protocol. Okay, you can have two protocols, that is from router to host, from router to server, like that. So now you just understand about one of that protocol that is called as the IGMP, Internet Group Management Protocol. So what is the importance of this IGMP is, it is a protocol that manages group membership. Okay, so if you are considering any network, one or more routers, multicast routers will be present. And they will be able to transfer or deliver the multicast packets to the host. Right? So IGMP, what it does is it enables communication between the router and the connected host. The host will be requesting, okay, I need the multicast traffic from a server. So making use of this IGMP protocol, you will be able to get that data. Okay, So what are the two main goals of this IGMP? Now you can see in the slides what the IGMP does is it enables communication between a router and the connected host. You can see it in the diagram. Now you have two main goals of this IGMP. One is to inform a local multicast router that a host want to receive multicast traffic for a specific group. That is one of its goals. And the next one is to inform the local multicast routers that the host wants to leave a multicast group. So that is the highlighted, I mean, join or leave. So you have a host, the router is connected to that. So IGMP protocol, what it will do is when a host wants to connect, get the multicast traffic, the IGMP protocol, I mean, the router will be making use of this IGMP protocol. The router will be, I mean, the server will be providing the multicast traffic to each of the hosts. Okay, so you want to inform your router. Here it is blue in color. So the local router, multicast router, I told in any network you are considering, you will be having many multicast routers. So the multicast routers should be able to deliver the multicast traffic from the server. Okay, now once the user group, if they want to leave the group, they can leave the group by informing the router. Okay, so the router, see, there is one drawback in this IGMP versions that I'll tell in a minute. So the two goals are you want to inform the multicast routers that the host want to leave a multicast group. Okay, so router has to figure out where is the server hosting the multicast application. Now that is the router's function. It should identify where the server is and which server is hosting the multicast applications. Understanding? So just IGMP group management protocol, you want to enable communication between the router and the connected host. So you're making use of this protocol, you can do that. Two goals. One is the router that the host wants to receive traffic from for a specific group, and it wants to leave a multicast group once it finishes its once it is accessing the multicasting traffic. So these two things are taken care by the IGMP protocol. Right? Now, you have got three versions of this IGMP. One is version 1, version 2, and version 3. In that version 2, you are considering as the default protocol. And when you are considering version 1, you will have two specific message structures in it. One is the report message, the other one is the query message. That is what we have seen in all the protocols that we discussed now. You have seen two types of messages. One is the report message and the other one is the query message. Now, report messages, they are used by the client to join the group. You are informing, the user is informing the router that they need to access the multicast traffic from a server, or they want to join the group. So that is sent through a report message. Okay. Now the next one is the query message. Query message, it is used by the router to see if the members of the group still exist. Sometimes if so many hosts are connected, sometimes maybe one host finished its collecting the multicast traffic and they will be sitting idle. So the router sends a query messages whether they still needs the multicast traffic. So that type of messages is in how it has been sending us in the form of query messages. Okay, so you have two specific message structure. One is the report message and another one is the query message. Right? So the whole meaning of IGMP is you are having a server who is hosting the multicast application. Now, the host want to receive the multicast traffic from the server, or the host want to join the group, right? The host wants to join the group so that they want to access the traffic from the server. So what it will do is it will send a report message to a router. So you can see it in the previous diagram. So if they want the multicast traffic, they will send a request message, or report message to the router. I need to receive the multicast traffic. So they are informing the router based on that. Okay. Now what the router will do? Router will communicate with the server. That is with some other type of protocol. So the router communicates with the server, right? Now, once the router is sending the multicast traffic to host, they make use of some query messages. So from the server, the multicast traffic is given to the host. Now the router again will be sending some query messages to the host whether they still needs that traffic. Understanding? Whether is the traffic is enough for them, or if the multicasting messages are enough for them, or still they needs that. Now how they are doing that? With the help of the query messages. Okay, so that is the difference between the type of messages. A report message and other one is the leave message or the query messages. Right? So report messages, they are used by the client to join the group such that they want to obtain the traffic from the server. Now, once the traffic is given, the router knows whether they still require that traffic. So in order to know that, they will be making use of this query messages. Right? Now, you have got a frame format for that we will be continuing in the next class. So just understand what I have told in today's class. I have just discussed about the 3 different types of protocols today. One is the dynamic host configuration protocol, then control message protocol, and the group management protocol. Okay, so you should read your textbook today itself, and I will be sending the slides today, and Tuesday within one more hour I will be able to complete the 3rd unit. And 2 hours, I think day 5, I have got 2 hours. So 1 hour I'll be completing the portions, and the next hour we will be having a revision class. Okay, so all of you, I will be sending the PPTs today. Refer the textbook, refer the PPT, refer your lecture notes, and get the concepts. What you have studied in your 3rd module. I'll be asking questions. You have to answer it. Okay, and by Tuesday, I will be giving an assignment for you for the unit 3. So that I'll be publishing it in Linbase. So 1 week time I'm giving for you. So complete that, and the next day you will have a unit test based on that. Okay, so read the textbook today itself and understand the concept. So 3 protocols, what we have learned is the DHCP protocol, ICMP, and IGMP. IGMP is meant for the multicasting process, and ICMP for error handling. DHCP is if you want to obtain the IP address to your device, you are making use of that protocol and you are obtaining your IP address from the server. Okay, is it clear? Yes or no? Yes. So, dear students, please read the textbook today itself, otherwise you won't be able to recollect the things what I have told. Simply listening the theory classes and you will be, easily forgetting the things. So once you read it today itself, something will be in your mind. Okay, so corrected your, almost 90% of your answer sheets has been corrected, but I'm not satisfied still how the way of writing, etc. and all. So, okay, let me, I will call upon individually and I'll tell what mistakes you have done in the next class also. So prepare for that. And okay, so absentees for today's classes are Tulya P, Neeraj, and Vaishna K. Right, I think the other staff has joined. Let me stop here. Thank you.